Hi students, this is Sriram, Associate Professor from Department of CSC. In this video, I am going to present a lecture on recursion. So, the recursion is a very important topic. Why? Because this is the one special kind of function, and we will see what is this recursion, how can we solve the problems using recursion, and how can we change an iterative solution to recursive solution. Let us start with the aim of the session. So the main aim of the session is to familiarize with the recursive functions, and then the instructional objectives of the section, understanding the concept of recursion, and identifying the recursive problems, and tracing and understanding the recursive execution. Coming to learning outcomes, once you complete the session, you should be able to define a recursive function, you should be able to implement a recursive algorithm, and you should be able to apply recursion to problem solving. With this view, we start the session. So first let us see what is a recursion. So as I told you, recursion is a special kind of function which calls itself either directly or indirectly. You know students, by using functions only we can incorporate modularity in our program. So when we are using functions, in some cases, particularly in some solutions, we have to call the same function again and again. So here we have one provision that is known as recursion, which automatically calls the function itself until we get the expected result. So we can say a recursion is a special kind of function which calls itself either directly or indirectly. And here students, when we are going to use this recursion, or when you call a recursive function, first point is the compiler executes the base case. Base case of the recursion is very important. Why? Because whether we need to continue the recursive call or not, that will be determined by this base condition. So this base condition determines whether we should stop the recursion call or whether we should continue with the recursion call. So that when we call the recursive function, first it executes the base condition. So how to frame this base condition and how to execute this base condition, that we can see when we are writing the recursion. And here when we call the recursive function, as we know that the base condition is executed, so based on the result of the base condition, the continuity of the recursion can be decided. Here if the base condition is not met, the recursive calling itself, so until the base condition is reaches. So when the base condition reaches, it automatically stops the execution of the recursive call, so that the continuity of the recursive call completely depends on the base condition. So that while writing the base condition, we should be very careful. Unfortunately, if you have committed any mistake in base condition, automatically the recursive calls enter into the indefinite loop. That's why while we are writing base condition, we should be little bit care. Now let us see what are the key components of the recursion. When we writing the recursion, we need to concentrate on four important components. One is the base case. So as I explained you, the purpose of the base case is to decide or to take a decision to continuity of the recursive call. For example, if I want to continue a recursive call, that will be decided based on the checking of the base condition. If base condition is false, it continue the recursive call. If base condition is true, it stop the recursive call. That is the role of the base condition. So this base condition is a very important component in the recursion. The second component is the recursive call. So as I told you, when we perform recursive solutions, you see once the recursive call is executed, so we have to call the same function recursively. So to call that recursive function repetitively, we should make a call. So how that recursive call can be performed? If you don't perform recursive call, then no need of the recursive function. So if the base condition is false, we need to perform the recursive call. Then only the continuity of the recursion can do. So if you don't make any recursive call, then what happen? The recursion will not execute. So that the recursive call is also very, very important. Next component is problem decomposition. Usually here the main feature of structured programming is modularity. We know that. So during the problem solving, here in particular in structured programming, we are going to decompose the problems into subproblems. Here also decomposing will take place, but here the problem decomposition is in terms of number of recursive calls. So for example, if I want to find out a solution for factorial value of a number, now for one recursive call, which number factorial value I have to find. For example, I want to find out the 5 factorial. For first recursive call, I can find out 1 factorial. For second recursive call, I can find out second factorial. For third recursive call, I can find out 3 factorial. Like that, I have to decompose the problem into number of recursive calls. The proper decomposition is very, very important. That is also another component of recursive call. The another important component is backtracking. This is a very important. Why? Because when we perform recursive calls, so actually when that one particular recursive call is completed, we only get intermediate result. We won't get final result. We won't get final result. That's why we should be careful about the recursive calls. These intermediate, if you don't properly handle these intermediate result, storing the intermediate result and reconciliating the intermediate result to get the final result, if you don't handle properly, we should not get the final result. So when that intermediate result was generated for each and every recursive call, that will be reconciliated. Once all recursive calls are completed, that process is known as backtracking. Let us see how this backtracking works with an example. So these 4 are the very, very important components when you are writing to when you are going to solve any problem with the recursion. And you see students, the recursive functions can be used to solve variety of problems. Like in mathematics, we can solve the factorial value, we can solve the Fibonacci series problem, and we can solve the sum of the problems in data structures. We can perform some searching algorithms and sorting algorithms. All those things can be done with this by using these recursive solutions. And we will see how we can do this recursion with an example. Here you can see students, this is an example to find out the factorial value of a number. Let us see how this recursion works. If you observe here, there are 2 functions. One is the main function, another one is the factorial function. So here we know that if it is a non-recursive function, we simply say the main function is a calling function and the factorial function is the called function. So fortunately here we are using the recursive function. We are using the recursive function. So let us see how this recursion works. And this if you observe this function is a non-recursive function. Why? Because here first I am representing this factorial value using the loop. So usually we call this is the calling function, this is the called function. Now here if you observe, when I call the function to find out the factorial value, the control comes here and it starts the execution. Initially the result is 1, and then with the help of the for loop I am taking the counter variable I. Every time the I is incremented and it is multiplied with the result, so that what happened, I can able to get the factorial value. This is the thing what we have done earlier. But now I want to change this function as a recursive function with this example. Now how can I write this? For that, first of all, I need to decide the base condition. What is the base condition here? I need to calculate the factorial value until n value reaches to some 1, that means r 0. We know the factorial value of 0 is also 1. So we can define the base condition like if I is or n is 0 or n equal to 1. Now if both are 0, that means if n is 0 or 1, we simply say the factorial value is 1 and I can write return 1. If it is not the case, what we have to do? In else part we have to perform the recursive call, that is we can say return of n into factorial of n minus 1. Like that I can perform the recursive call. Here I can define the factorial function into factorial of into n. This is the recursive function. Now we can observe, if I use this recursive solution here, what happened? The control goes to here when I call this. Now it check the n value. Let us consider n value is 4. Here it will check, is n equal to 0 or 1? No, it is not 0 or not 1. So it go and execute a return of n into factorial of n minus 1. N means 4. 4 into factorial of n minus 1. That means n minus 1 means 4 into factorial of 3. Now I am calling factorial of 3. Again the function comes here. Now what is the n value? 3. Again check the condition, not 1. So it goes to the else part, execute 3 into factorial of 2. This is second recursive call. Again control come here. Now what is the n value? 2. Check the condition, is n equal to 0 or 1? No. So it comes to the else part. Again it call 2 into factorial of 1. Again control come here. Now it check the n value. Is n equal to 0 or 1? 1. So it return 1. Now 2 into factorial of 1. That means the factorial of 1 is 1. So now we start backtracking. 2 into 1, 2. Now the factorial of 1 is 1. So 2 it is. Now the factorial of 2 is 2. 3 into factorial of 2. Now the factorial of 3 is 6. 4 into 6, 24. Like that we do the backtracking operation. You can observe how it happens. For example, factorial of 3 if you taken, then it can perform like this. Factorial of 3, 3 into factorial of 2, 3 into 2 into factorial of 1. Like that it will happen. When it is coming to the n value 0 or 1, it returns 1. So here what is the base condition? This is the base condition. That means if we met this base condition, your recursive call stop executing. Otherwise your recursive call continue like this until we meet the base condition. And once all the recursive calls are completed, we start backtracking by substituting the intermediate result in intermediate recursive calls to consolidate the final result. This is the way how we can write this factorial recursive function. I hope everyone understood. Let us move to the next another example here. Here I want to find out sum of the digits of a number using recursive call. This is a second example. Okay, let us see how it works. So here you see, first I define a function. This is known as function prototype, you know that. And in main function I am taking a number as input, and then I call the function sum of the digits of n. Now when I call this function, what happened? The control comes to here. Now it check the condition. If n equal to 0, that means no digits, nothing to do, we simply return 0. Now I can say this is the base condition for the recursion. This is the base condition for the recursion. Else, what we have to do? We have to extract individual digit to find the sum. That's why what we are taking return of n mod 10. For example, let us assume I am taking n value is 153. Now what happened? Return of n mod 10. N mod 10 means 3 plus sum of digits of n by 10. N by 10 means now what happened? It is 15. What is this? It is 15. Now what happened here? Again the recursive calls takes place by taking n value as 15 and it is 3 plus a sum of 15. Again it come here. Return of n mod 10, that is n value, now it is updated to 15. 15 mod 10 means again 5. 5 plus sum of digits of n mod n by 10. Now we get the 15 by 10, 1 as the quotient. Again another recursive calls takes place. Now n value is 1. Again it check the condition. N is 0, no. It go to the else part. Again it take. Now it take n mod 10. 1 mod 10 means 1 plus sum of the digits of the n by 10. 1 by 10, that is 0. Again recursive calls takes place. Now it will return 0. Now here it is sum of this one is 0. 1 plus 0, 1, and 5 plus 1, 6. 3 plus 6, 9. Like that the backtracking will take place. Now here what happened? For example, you see in this example we have taken 5754 as a number. Now here what we have taken, first we call the digits of sum of 5754, then 4 will be taken. Like that it continue the recursive calls. Once all the recursive calls are completed, the backtracking will be performed from bottom to top and we consolidate the final result. Now sum of the digits is 21. You can check the sum of the digit. 5 plus 7, 12. 12 plus 15, 16 plus 5, 21. Like that we can take the recursive calls. This is another example. By looking at, you can understand how the recursive calls work. Now you can see until now we have seen how to write a recursive function and how can we define a recursive function. Okay, here students, usually in most of the cases we are going to solve some problems using iterative algorithms, but it is possible to write some of the iterative solutions in recursive manner. Okay, let us see how can we do this. Okay, we will see how can we convert this iterative solution to recursive solution. So whenever we want to convert an iterative solution to recursive solution, we follow 4 main steps. First thing is we have to identify what is the base condition. Just now we have seen how to write base conditions for factorial value problem as well as sum of the digits problem, and then which portion of the function we need to repetitively execute, that we have to determine, and then we have to define the recursive function and we have to implement the base case. They are the 4 important steps we have to follow whenever we want to convert an iterative solutions to the recursive solution. Now let us take this activity by considering a normal iterative solution, how we can convert to the recursive solution. Just now I discussed here. Here I am taking a factorial value. This, if you look at this one, this is the iterative solution. That means I solve this problem using for loop. The same problem I have rewritten by using recursion. You can observe here. So based on this for loop only, I can determine the base condition. Here what is the condition in for loop? I less than or equal to n, and I value start from 1. So here I can decide the base case based on this condition. That means I can get the factorial value until I reaches n value to 1 or 0. Like that I can derive the base case. So that base case we have to write. And what we have to done if we reach it to the base case? You know students, the factorial value of 0 is also 1. That's why we simply say if n is 0, we return 1. Like this we need to implement the base case. If it is not the case, if n not equal to 0, then it go to the else part and it execute this return statement, that is 1 into, that is n into factorial of n minus 1. Let us consider here if n equal to 5, then it will implement as 5 into factorial of 4. Now a recursive call will take place. Here what happened in the iterative solution, we simply write the for loop and that will repetitively execute one statement, that is the result into result star I. It will give the final result. But here based on this I defined what is the base case. I defined which part I need to execute. I need to execute this part repetitively, recursively, and what the way how that means I identified which operation we need to perform recursively, that is a multiplication operation that I placed here. Like that, by looking at the iterative problem, we can rewrite the problem in recursive way. In this example you can observe that. Okay, this is the best way to understand what is the use of recursion. That means from this example we can understand that most of the iterative algorithms can also be implemented by using recursive solution, but it is not advisable to write recursive solution for all the algorithms, but the algorithms which are good enough for recursive solutions, those you can take these recursive solution, otherwise let them do in only iterative manner. So if you observe this session, what we have learned in this session, we discussed about the recursion and the process of the designing recursive solutions, and we discussed that how to convert an iterative solution to a recursive solution. But finally what we can conclude that here we can convert all, we can write all the iterative algorithms to the recursive algorithms, but in some cases, okay, we cannot write all the algorithms, only the most suitable algorithms can be rewrite using recursion. And before going to close the session, let us check some of the self-assessment questions what we have included here. Let us see the question: state true or false, sum of the natural numbers can be solved by using recursion. Actually we solved this problem using iterative statements. Is it possible to solve? If it is possible to solve, what we have to do, we have to define the base condition. That means we need to add all the numbers from n to 1, because the natural number starts from 1 and they end at 1. So is it possible to define the base condition? Yes. Which operation we need to recursively perform? Addition operation we need to perform. So like that it is possible to implement the recursive solution to find out sum of natural number, that is true. Second question: how to determine that when the recursion should stop? So based on the base condition. The base condition only determines whether to execute the recursive call or not. If we reach the base condition, we stop the execution of recursion, otherwise we continue the execution of the recursion. And for your convenience, we have included some of the terminal questions. Please prepare these questions so that they are very useful. So what is a recursion and what are the main components of the recursion, and develop a recursive solution to find out sum of the digits of given number. Is it possible to convert an iterative solution to recursive solution, and explain the procedure. So by answering these questions you can clearly understand how recursion works. And they are the some of the books and references links provided to you. Please go through these references so that you can get more knowledge on the recursion concept. I hope students everyone understand. Thank you very much.